One of humanity's greatest challenges has always been to understand and harness the power of the elements, the strength of wind, and the force of water. This quest inspired history's greatest minds to develop the science of fluid dynamics and its equations. These equations are nothing short of genius and extremely difficult to solve. They're so complex, in fact, they cannot be solved by hand. This all has led to a software revolution that uses methods and algorithms to predict how liquids and gases behave and how they work with the products we design. In the design world, we call this computational fluid dynamics, or CFD for short. Fluids affect the performance of almost every widget, device, and structure. CFD is an important part of the design equation and helps boost energy efficiency, reduce risk, and spark innovation. Fluids are always a serious factor. It takes energy to move a car down the highway or to pump water through a pipeline. By understanding the forces and effects of fluid dynamics, you can make the critical design decisions that reduce energy consumption and improve efficiency. Products, vehicles, and structures often fail due to miscalculations or judgment errors of fluid behavior. We hear about these malfunctions all the time. Computers overheat, car parts fail, structures collapse in high winds. The result is recalls, lawsuits, or worse, loss of life. By running CFD analyses throughout the design process, you can solve these issues before they turn into serious problems. Costly physical prototype testing provides discrete pieces of test data. CFD analysis shows you the complete view of the flow. This insight inspires questions and critical thinking that produce innovative design. Fluid flow is the study of how liquids and gases move in and around solid objects. Heat transfer is the study of how things heat and cool and the cause of these temperature changes. With CFD analysis, you can understand the flow and heat transfer throughout your design process. A few examples include wind resistance of a car or motorcycle, pressure drop through a water valve, component temperatures in an electronics enclosure, comfort of people in a crowded meeting hall. And that's just the start. CFD analysis should be used throughout the design process to gain insight and to make good design decisions. Let's follow a project timeline with CFD. Let's say you get an assignment from a client and right away you have an idea, a seemingly groundbreaking solution. You think it will work, so you mock it up and run a CFD analysis. You learn some things, you get precise information. You land on a concept that will drive the next big thing. As you work out the details, you must consider every question carefully. You iterate through each alternative and select the best. Each analysis unlocks a secret that will make your design better. Finally, you analyze a detailed model to check that it all works as designed. You spot an issue. You fix it, then rerun to make sure it's fixed. The result is a high-quality product delivered on time. Your customers are happy and you're ready for the next big challenge. Now that you've had the rundown on CFD, take a look at the tutorial videos. Start seeing the benefits of simulating in your workflow.